Ever heard of the fountain of youth? Well, what if it wasn't just a myth?
Intriguing.
Today, we're diving deep into senescent cells. You know those zombie cells scientists think might be behind how we age?
And maybe even how long we live.
Right, exactly. We're looking at this really interesting article, actually. It's from a Korean publication
Oh, wow.
called Okay, Yo, Great Yogo,
Right.
which roughly translates to removal of senescent cells, the key to extending healthy lifespan.
This is promising.
It's pretty wild. We're going to be talking about genetically engineered mice living way longer than normal.
Like way longer.
And what that could all mean for us.
So basically, we're talking about adding life to our years, not just years to our lives.
Exactly. Extending that health span.
Yeah, not just the lifespan.
So to start off, what exactly are these senescent cells?
Well, they're cells that have stopped dividing, unlike normal cells, but they just kind of linger around.
Oh, so they're like squatters.
Kind of. They make up a tiny percentage of our cells, but they can cause some big problems.
So what's the big deal about these lingering cells? Why are they so bad?
Well, the thing is, they release this whole mix of inflammatory molecules. It's not good.
What do you mean?
Basically, it's like they're constantly sending out these tiny little alarm signals, creating chronic inflammation. And that's linked to like a ton of age-related diseases, diabetes, stroke, osteoporosis,
Wow.
even Alzheimer's.
Seriously?
Yeah. And you know what's kind of eerie? Scientists can actually track these cells down using this special stain.
How does that work?
They literally turn blue under the microscope.
Oh, wow.
So they really do kind of look like zombie cells.
Okay, that's creepy. But I'm curious, if they're so bad for us, why do we even have them in the first place?
Now that's where things get really interesting. Turns out they're not always the villains.
Oh.
Yeah. In early development, they're actually super important. Like they help shape our organs and tissues. And then when they're not needed anymore, they get cleared away. Think of it like a built-in cleanup crew.
So it's not the cells themselves, but what happens to them as we age.
That's it. As we get older, our immune system doesn't clear them out as efficiently.
Ah, I see.
They start piling up, and that's when the real trouble starts. Like their inflammatory messages start drowning out the normal cellular signals.
Leading to problems.
Exactly.
So we've got these cellular squatters overstaying their welcome and causing chaos.
Pretty much.
This article talks about our getting rid of them, right? Is that where these senolytics come in?
You got it. Senolytics are drugs that specifically target and destroy senescent cells.
Interesting.
And early research, especially in mice, it's really remarkable what they're finding.
Like what?
They engineered these mice so that their senescent cells could be eliminated with a drug, and guess what?
What?
They lived a whopping 36% longer than normal.
Hold on. 36%?
Yeah. And they were healthier overall, too, with fewer age-related problems.
That's incredible. So if it works in mice, what about humans? Are we talking about a real-life fountain of youth here?
You know, there's reason to be optimistic, but cautiously so.
Okay.
Researchers found that a combination of desatinib, a cancer drug,
I've heard of that one.
and quercetin, something found in apple peels,
Apple peel.
can act as a senolytic in humans.
Wait, apple peel. So like an apple a day really could keep the doctor away.
Ha, not quite that easy.
Yeah.
It's more complicated than that.
Right.
But, you know, we're still in the early stages of human trials. Like, there was this pilot study on a lung disease called idiopathic pulmonary fibrosis.
Okay.
Patients who got that desatinib and quercetin combo
Yeah.
saw some improvements in their physical function.
Mm.
But we really need larger, more conclusive trials.
So no living to 150 just yet.
Not quite. But the potential here is huge. Imagine a future where we could target aging itself, not just the diseases that come with it.
It's a lot to think about.
It is.
And this is just the beginning of our deep dive. There's so much more to explore. Wow, apple peels, huh? Who knew?
Yeah, it's pretty amazing, isn't it? And you know what's interesting? These senescent cells aren't just a simple on or off switch.
What do you mean?
They're actually incredibly complex. Like, their role in our bodies is, well, anything but straightforward.
That's true. You mentioned earlier their strange connection to cancer, right?
Right.
How can they be protective against cancer and then also promote tumor growth?
It is kind of a head scratcher.
Right.
Think of it this way. Sometimes these senescent cells, they're like the brakes,
Okay.
stopping damaged cells from becoming cancerous, which is good.
Right.
But then the inflammation they cause can actually fuel the fire
Oh, wow.
and actually help tumors grow.
So it's like a double-edged sword.
Exactly. It really depends on the specific situation.
So context is key. That must make developing these senolytic therapies
Oh, yeah.
like walking a tightrope.
You got it.
Yeah.
We don't want to just wipe out all the senescent cells because, remember, they do have those benefits.
Right.
Like, we need to be able to target the troublemakers,
Right.
but keep the helpful ones around.
Gotcha. So more research is needed.
Absolutely. We need a deep understanding of how they behave
Okay.
and how they interact with other cells.
So it's back to the lab.
It is. But, it's not just about living longer. It's about living better.
True. Yeah.
It's about enhancing that health span,
Making sure those extra years are good years.
Yeah, filled with vitality,
Yeah.
not just more time in the doctor's office.
Now that's a future I can get behind.
Right.
But realistically, what are the challenges that researchers are facing when it comes to these senolytics?
Well, one of the biggest hurdles is how to target these cells with more precision.
Oh, okay.
Like dasatinib and quercetin. That's a good starting point,
Mm-hmm.
but it's not perfect, right? We need more specific, more targeted therapies.
I see.
Some researchers, they're even exploring gene therapy as a way to deliver these senolytics directly to the cells.
Oh, wow. So like a guided missile.
Exactly. And then there's the question of dosage. Too much could be harmful.
Right.
Too little might not work. It's likely that the optimal dose is going to be different for everyone,
Makes sense.
depending on their condition.
Yeah.
Personalized medicine, I think, is going to be a key part of this whole thing.
I agree. Because we're all different.
Yeah.
It makes sense that our treatment should be different too.
Right.
But how do we even find those senescent cells in the first place? I know you said scientists can stain them blue.
Right.
But we're not going to be doing that to every patient, are we?
No, definitely not. That's why researchers are working on these biomarkers.
Biomarkers?
Yeah, measurable indicators in the blood or urine that can signal the presence of these cells. It's like they're looking for fingerprints at a crime scene, basically.
Wow. So we're basically playing detective with our own cells.
Kind of. We're only beginning to understand how complex this whole aging process really is. And it goes way beyond just wrinkles,
Right, of course.
It affects every cell in our bodies.
Yeah.
But by understanding those complexities, we might actually be able to unlock some really groundbreaking therapies.
Okay, so much to think about here. But before we get to those more futuristic applications like space travel and organ transplants, we need to think bigger, right?
Absolutely.
We're talking about extending human lifespan, maybe significantly?
Potentially, yeah.
What kind of impact would that have on society?
That's a really important question. It's not just about adding years. It's about how those years impact our healthcare,
Yeah.
our economies,
Wow.
our relationships, even our understanding of what it means to be human.
Okay, those are some deep waters we're wading into. Are we even ready for a world where people routinely live to be 120, 150, or even older?
That's the million-dollar question, isn't it? And I don't know that anyone really has the answer yet.
Right.
But we need to start having this conversation now,
Okay.
before these things become a reality.
It's just like we're standing on the edge of a new era.
We are.
And we need to decide what kind of future we want to create. It's exciting,
Yeah.
but also maybe a little bit terrifying.
It is. And it's not just about the science. It's about how we use that science to build a better world.
Absolutely.
For everyone. We have to make sure these technologies are used responsibly and ethically for the benefit of all humankind.
Well, you've officially blown my mind wide open.
Good.
It's so much bigger than just living a few extra years. It's a potential paradigm shift.
It is. It could change everything about how we live,
Wow.
how we work, how we age. We're entering uncharted territory here.
It is. It's exciting, but also a little daunting.
It is. But I think that's what makes it so compelling,
I agree. I, for one, can't wait to see where it all goes. But, we need a moment to process all of this. It's a lot to digest.
It is.
Welcome back, everyone. So we've been on this wild ride exploring these senescent cells. Are you ready for liftoff? Because we're about to blast off into some seriously futuristic territory.
I'm strapped in and ready to go.
Perfect. We've talked about extending lifespan, health span, all of that. But this research, it could go way beyond what we've even touched on.
Oh, absolutely. The implications are huge.
Let's talk space travel.
Okay.
One of the biggest challenges for astronauts, right, is that accelerated aging from all that cosmic radiation.
Yeah, it's a problem.
Could these senolytics protect them during those long-duration missions, like to Mars and beyond?
Well, researchers are actually looking into that right now. They're studying how space radiation impacts those telltale markers of senescence in astronauts.
So they're trying to figure out if space travel basically puts those cellular party crashers into overdrive.
Exactly. It's like, does space travel make them go wild?
And if there's a link, Could senolytics become like standard issue for astronauts?
It's definitely a possibility. I mean, imagine, right, helping them stay healthier on these deep space voyages.
Yeah.
And then think about organ transplantation.
Oh, right.
We're throwing away thousands of organs from older donors every year because they're considered too risky.
Yeah.
What if we could treat those organs with senolytics, make them suitable for transplant?
I was reading about some research where they did that with mouse hearts, older mouse hearts.
Right.
And the treated hearts, they work just as well as the young hearts after they were transplanted.
It's amazing. I mean, think about it. We could be giving people a second chance at life through organ transplantation.
Yeah.
It's huge.
This is all incredibly exciting, but are there any downsides? Could messing with these cells, I don't know, backfire in some way?
You know, that's a great question. And you're right to be cautious.
Yeah.
We've talked about it before, right?
Yeah.
These senescent cells, they do play a role in things like development and wound healing. So just wiping them all out, probably not a good idea.
Right.
That's why researchers are working on these really targeted therapies.
Okay.
Get rid of the bad guys,
Uh-huh.
but keep the good guys around.
So like precision surgery, not just going in with a wrecking ball?
Exactly. And as with any new therapy, we need more research
Of course.
to really understand the benefits and the risks.
This has been an incredible deep dive.
It has.
We've gone from these tiny little cells to space travel
Right.
to organ transplantation.
Amazing, isn't it?
I feel like I've aged backwards just by talking about all of this.
Who knows what the future holds,
That's
right?
right.
I mean, maybe someday we'll look back and think, how did we ever just accept aging as this inevitable decline?
It's an exciting thought. So to everyone listening out there, stay curious.
Yes.
Keep asking questions. And remember, the quest for a healthier tomorrow starts today.
By understanding our bodies.
Exactly. Thanks for joining us on this incredible journey into the world of senescent cells. And we'll catch you next time on The Deep Dive.